जी जनाब, अस्सलाम वालेकुम। Last time we started off with user-defined types, and today we are, and we did discuss those. Today, walaikum assalam, sir. Today we are going to solve few questions that I have extracted from past papers of A2 or P4. Since all these user-defined types or abstract data types, they all have floor crossed from P4 into P2, and they are not as complicated as they are in P4. So I had to copy all the questions and remove all those parts which are not part of P2. I have made a document of all the past paper questions which are related to the ideas, description, and concept of abstract data types. So let's start. Okay, now this is basically October, November 2003. By using diagram or otherwise explain how a data item can be inserted into and read from or deleted from a queue held in an array. All right, so first we have to, when we are inserting, insert into queue, when we are inserting, first we check if queue is full. Then we insert at location mentioned by rear pointer, rear or tail pointer. All right, and then we increment rear or tail pointer. If we go pictorially, let's say this is tail pointer, or let's say there are already two items, A and B in there. So this is tail pointer and this one is head pointer. We know that we remove the data from head pointer and we add the data at the tail pointer. So when we add an item, we move the tail pointer forward and add the item at that tail pointer. But this can only be done until unless we have a space in the array. So if we like to read from queue, read from queue or delete from the queue, the first thing that we would have to check for the error if queue is empty. All right, and then we have to first increment the head pointer. Or front pointer, whatever you call it, and then we read from the position of head pointer in array. So in this case, what will happen that if we like to read an item from the queue, since queue is first in, first out, so obviously we will first increase the head pointer from the base or from the null position to the first, as in head pointer is equal to head pointer plus 1, and then a will be read. So that is how we will do it. It says explain a problem that could arise when storing a queue in an array and state the possible solution. You see, by nature, queue is dynamic. Now there are two types of data structures. Data structures or ADT types. There are two types. One dynamic, the other one is static. Queue, stack, and linked list are by nature, as in their definition, are dynamic, whereas array is static. Now, all those data structures which, while the program is being executed, can grow and shrink as much as possible are called dynamic. And those data structures like array, when we program the size of the array. The array cannot grow, cannot shrink while the program is being executed. If you like to change the size of the array, you would have to stop the program, open the source code, change the size of the array, and then you would have to re-execute. Such type of data structures which cannot grow or shrink while the program is being executed are called static data structure. Now the thing is that the queue and stack does not have their own data structures as in the array and linked list. So if we like to execute a program for queue or stack, either we implement queue or stack with array or with the linked list. Now in your syllabus, even queue, stack and linked list will be implemented using the array. So let's just take it by its nature. So if queue and stack are conceptual data structures and they can only be implemented using the linked list or array. So if the queue and stack data structures implemented using linked list, which can grab the memory on the go when it is required to increase its size or leave the memory when it does not require one node to be held, means it is dynamic. In that case, queue and stack will both be regarded as dynamic since they are implemented using linked list. On the other hand, if the queue and stack are implemented using the array, they will be regarded as static data structure because the size of the array cannot change. So now that is one of the problems if the queue that we have here in this question, if we implement it using the array, array may get filled because array is static and queue is by nature dynamic. So it is a good idea to implement uh, uh, the queue using the linked list. All right. So explain a problem that could arise when storing a queue in the array. Array is a static. You can go for one particular size, which is the size of the array. Above it, it will not be possible. So it is a good idea for the possible solution that we implement the queue using linked list. Now, second question. A stack is to be held in an array with the aid of diagram. Explain how an item may be added to or deleted from the stack. So let's say we have this stack that is having two items, A and B, and stack pointer is pointing at B. So if I like to add as in push, add as in push, what I would do, I will move the array pointer one up, increment it, and then I will push. If I like to pop, so this is push operation and this is pop operation. So if I would like to pop, B will be popped and stack pointer will come down. So that is how it works. So this is a stack pointer or top of the stack pointer. Now, if we write a little algorithm for it, so for push, we will have to first check if the stack is full. Again, the stack will get full because it is held in an array. Okay. Check if a stack is full. Increment the stack pointer at the value at stack pointer position in array. All right, at the value in stack pointer position in array. And then we have got pop. So if we like to pop, first we have to check if stack is empty. If it is not empty, then what we do, we read from stack position. We read from stack position and then we decrement the stack pointer since the item that was meant to be read is already read. Now, next question. Explain the difference between static and dynamic data structures. Explain the difference between static and dynamic data structures. Okay, so we have already discussed it. Let me revise it for you. Static data structures, they do not grow or shrink while the program is being executed. The static data structures do not change size. Static data structures do not change size while the program is running, while the program is running. Whereas the dynamic data structure can change size according to the requirement, can change size according to the requirement of the program. All right. While the program is being executed. Now, what are the static data structure examples? That is array. And what are the examples here? It is linked list. Okay. Now, data structure given an advantage of each. What is the advantage? I told you that you can increase the size, you can decrease the size. And if it is array, you know what is the maximum size and you can plan accordingly. In linked list, you can increase the size or decrease the size as per the requirement. So everything has got their own benefit. Explain the difference between dynamic data structure and static data structure. This is a common question. Further, if it will appear, I won't answer it since we have already discussed it. Now, May June 2007. Now, it says that jobs that require printing by a network printer are stored until the printer is ready. As you can see, the nature of the jobs which are being printed is basically first in, first out. Whoever will send the print to the printer over a network printer in whatever the chronological order or the time order, it will get printed. No matter the job is bigger or smaller, whoever sent it first will get it first. Who sent it in the end or at any point of time, they will get it in the same order. So jobs that require, so it means that the order will be first in, first out, which is basically a queue nature. All right. Jobs that require printing by a network printer are stored until the printer is ready. The addresses are placed in a queue to await their turn for the printing. Addresses of the new jobs are placed at one end of the queue. All right, so queue is sort of this tunnel. Jobs are placed from one end and they will get out from the other end, and the order will be first in, first out. It's like a car entering the tunnel. Their addresses are placed in a queue to await their turn for printing. Addresses of new jobs are placed at one end of the queue. These job addresses are taken from the other end when the printer is ready. State two reasons why it would be preferable to store the queue in the linked list rather than array. Now you can see the array may become full because of a lot of jobs sent for the printing. Linked list does not needlessly take up space in the memory in a way that it can grow. When the number of jobs grow, let's say printer is switched off for a longer period of time and people who are sending the jobs or keep sending will not be limited, because the queue which is holding the token for the jobs or the ID for the jobs can be increased as much as required. Print jobs may be inserted into queue if they have high priority. Now, this is how it works. State two reasons why it is preferable. So, all right, The queue is held in the linked list. Describe an algorithm for inserting an address into the queue and reading an address from the queue. So this would have the same algorithm as we have discussed over here. As I doubt that you will be asked for any pseudocode writing because it is explicitly written in your syllabus that you are not expected to write any code, but a code which is as easy as this, as simple as this, you should know of. All right, so let's just move on. November 2009, November 2009, P31. This is basically from A2, so questions appear this way. A school is designing a computer system to satisfy its administration requirement. The head teacher, the system administrator, and 5 office staff will all require regular access. It is decided to use single large computer with a number of terminals to satisfy the demand. There used to be a time when there were computers known as mini-frame and mainframe. Mini-frame and mainframe. Mini-frame and mainframe had one gigantic central processing unit, the whole box, with higher storage, higher memory, and greater processing. And they had several linked dumb terminals. Dumb terminal as in there were keyboard, mouse, and monitors, but the whole processing was being done at the central processing unit, which is linked using wires. So this used to be a case. Now I still remember the last very famous mini frame computer was AS400, I believe, from IBM. It was very popular. So these used to be a single processor, central processing unit with lots of terminals, and those all terminals used to be dumb. So they are referring to that type of computer, which is either mini frame or mainframe. These mini frame and mainframe, with the passage of time, got replaced with web servers, because when mini frame and mainframe were there, the era of networking was not there, and internet was not there as well. So now everything is being controlled by the servers over the networks or over the internet. So the part D, the student records are stored using direct access with full index based on a student name. The index is arranged in alphabetical order of the student name. So this is linked list. As I told you the other day, that linked lists are actually ordered linked list. The index can be stored in static or dynamic data structure. Okay, state an advantage and disadvantage. So we have already discussed the advantage and disadvantage of it. Advantage is searching is quicker because we know that we are searching something which is in order. So if the thing is not in order, let's say you are searching for a name that is Kerry. Kerry starts essentially with C, but somehow you have reached to Douglas. So it means that since Douglas has reached, if Kerry would have been there, it would have already been found. Since Kerry was not there, that is why. So if it is not in order, we only know if Kerry exists until the whole list is read. So this is one of the advantage. The searching is quicker. Disadvantage, when we like to add new items to it, we want to change the index or something. In that case, we would have to write the bigger algorithm to insert the values in between to maintain the order. All right. Now, part 2 is done. It is Part one is done. Part two is it is decided to store the index as a linked list. Describe an algorithm for the insertion of the new. So we are going to skip this since this is not part of AS. We will study it in A2. There is a question. We need more as constant content. We are trying. We always try. Now, Sukun. Hello, sir. The type of the questions being set as from 2018 are quite different. Do you share the view? Son, the thing is, things are being tried in the past papers, recent past papers, as you have already mentioned, as per the concept. All right, so you have to clear your concept. They are trying it with a different approach. That is true, but that all depends over the concept. So you have to keep your concept clear, and it's not just that you know of it. You have to actually know all the areas where such things or concepts can be implemented. So the questions are more of the type which are basically scenario based than the concepts or the regular concepts. Sir, we do appreciate your efforts and time consuming YouTube Live, but would you would like if you could go through question paper as from let's say 2015. Let me finish this. I would have few sessions in coming weeks, coming 2-3 weeks, where I will only be going through past paper questions, latest to oldest order. Hopefully, yes. All right. Now, May June 2011 P31. May June 2011 P31. Question 8A. It says explain the difference between static and dynamic implementation of the data structure. As you can see that this question is basically very important now, as I have seen it like 5-6 times already in 5 years. So this question might appear. Welcome Super. Give one advantage and one disadvantage of storing queue in array rather than in a linked list. All right, so I told you already the advantage would be array is a fixed sized which simplifies the algorithm. All right, an array can be used to control the maximum size of the queue, that queue does not grow unnecessarily. Whereas disadvantage would be keeping of this thing in array would be queue held in an array cannot expand beyond the size of the array. That is the limitation of the queue. And if queue is small, then memory space is wasted since array remains of the same type. All right. Draw a diagram to show how the following members of a computing class can be stored in a linked list in alphabetical order. As we know that linked lists are always in the order. They are ordered linked lists. So this one is the first A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T. So I have actually ordered everything as per the first letter. As when computer judges string values and compare them for the order, it first looks for the first character. If the first character is same, then it looks for the second. Otherwise, the whole string is meaningless for computer. All right, if it would have an idea of the order using only the first character. So we have start pointer or list header, whatever you call it. This is a pointer that points to a node where we have saved BEV. this is then pointing to FRO, then no, this is pointing to DON, DON, and then DON is pointing to FRO. FRO is then pointing to ROS. ROS is pointing to TSI, and then TSI is pointing to nothing. So this is said to be the list header. List points to the first item. This is called a node, where this is the data and this is the pointer. As we have learned in the past lecture, that a list is a combination of scattered nodes in the memory. They are not consecutive, and whenever we keep the data in the list, it is in the order. So list header points to the first node to the second, second to the third, third to the fourth, and fourth to the fifth. Now, we can also keep it in the array as they have mentioned it. And as you can see, let's say we have got an array. So the start pointer or the header is equal to, so this is 1, 2, 3, 4, 5, 6, 7, 8, and it is fro, and then TSI, then DON. I am entering the data as in this order, and then we will use pointer to point to them in order. DON, ROS, and BEV. So it means that we have free list as well, which is starting from 6. 6 is pointing to 7. So this is data, this is pointer. 7 is pointing to 8, 8 is pointing to null, 0. And header is actually pointing to BEV, which is at 5th location. 5th location is pointing to 3rd because there is DON. DON is pointing to fro, which is 1. Fro is pointing to ROS, which is 4. ROS is pointing to TSI, which is 2. And TSI is pointing to null. Okay. Sir, does not any array start from index 0? Index 0 can be used, but for AS level, mostly they start from 1. It really does not matter. Okay. So that is how we actually do it. All right. So there is a free list as well. Free list is pointing to all the nodes which are free and available for the other nodes too. Other lists nodes, other lists. So free list is a list which is available there, and it can be taken node by node from the start of it or any of the other lists. Now, May, June 2012, May, June 2012, P33 and 32. Now, what it says, a A linked list is to be implemented. So this is the concept of implementation. You have to clear your concept. Once you would have an idea of the concept, you will be able to answer such questions. Otherwise, it is not possible at all. All right. So that is what they mean by the concept and implementation, possible implementation of that concept into syllabus. So we would have to answer with reference to the context in the question. Anyways, a linked list is to be implemented when the data structure described in the variable table. Nowadays, in your syllabus, we call it identifier table. The countries are to be organized in the alphabetical order. Okay, so we can see that this is our array for countries and the array with the pointers. So we can see that it is starting with B, which is Bangladesh. So the head pointer will be 5. Bangladesh will point to 4, which is Colombia, and Colombia will point to 2, which is Denmark. Denmark will point to 3, which is India. India will point to 7, which is Mauritius. 7 will point to 6, which is Nepal. Nepal will point to 1, which is Sweden, and Sweden will point to null. This way, when we peruse, we read, we study this list in order, we'll start from head pointer, which is 5, Bangladesh, then 4, Colombia, then Denmark, then India, then Mauritius, then Nepal, and then Sweden. That is how we will be able to read the list in the order. So that is one thing. Other part, a linked list is maintained for capital cities using the array's capital and pointer. Now this time they have not used user defined type arrays, rather they are keeping over here and here 2 single dimensional arrays. One as the, this is basically the AS way mostly you might see in an exam, but you might have one single array with data and pointer thing. These are 2 single dimensional arrays, all right? And this is one user defined type array. So be prepared for both. Okay. Now, part D. A linked list is maintained for capital cities using arrays capital and pointer. An algorithm is required to delete values from the linked list. The algorithm will use the following variables: current and previous. The following diagram shows the first 3 capitals in the linked list. We are about to delete Canberra, which is the capital of Australia. The list has been searched from the head pointer position until the capital to be deleted, Canberra, is found. So Canberra requires to be now deleted. So how do we do that? Search the linked list until the delete value is found. This is basically the algorithm, sort of. Search the linked list until Canberra is found. All right. Once we have it, this is, you see, they said that there are 2 pointers, previous and current. So previous pointer is this, and the current pointer is this. So all we have to do is to connect previous to current. So if we make Berlin's pointer 7, it means Canberra is gone, isn't it? So 5 goes Berlin, Berlin goes 7, which is Dhaka, and Dhaka goes on. So we have got this array pointer. So pointers location, previous pointer location, which is previous, means we are pointing to this 5 Berlin. Number 3 becomes pointer arrays current. So current is 7 and previous is 3. So this 3 will become 7. As soon as you do that, you connect Berlin with Dhaka. All right, so this way we update pointers in pointer array job is done. You see, do not attempt writing any algorithm. Describe the steps in algorithm to delete Canberra. This is very simple. So we are at this particular location. We have an idea in the previous variable that from where we are coming over here, and that previous pointer will then be changed to the next pointer. That is how we will be able to update it. Now, October, November 2012. P32. Describe the operation of a stack data structure. A stack is to be implemented to store string data using the following variables. So my stack, this is an array of 100 locations on top of a stack pointer. The diagram below shows the state of array and top of stack pointer after the following. 3 values have been pushed. So what are those values? Owl is pushed, then line is pushed, and then we have got tiger is pushed. So obviously stack pointer is pointing to number 2 where the tiger was. The value is popped from the stack, so it means that tiger is gone, owl is there, and line is there. Okay, so the stack pointer has come down, and then the value leopard is pushed on the stack. So now this is the situation. Owl, line, and then leopard. And pointer is now pointing to. So this is the original position. One value is popped, and then one value is pushed. All right, what they are popping a single value is to be implemented with the procedure pop from the stack. So that is very simple. Procedure pop from the stack, which is basically, all right, so we missed out this one. Describe the operation of a stack data structure, that is last in, first out. That is last in, first out. Or we call it LIFO. So what is the operation of stack, last in first out? What is the operation of queue, first in first out? And then we are doing this part 2. Part 2 has got what? Part 2 has got this. So if then stack is already empty. So if it means that top of the stack, if it is lower than 0, which is -1, then it is empty. So if, what is the name of pointer? Top of stack. So if top of stack is equal to -1, then output stack is already empty, else my stack, over here we will write top of stack. It is then popped, and then top of stack will be decremented. So top of stack is equal to top of stack -1. So this is a simple algorithm which they like you to write up. All right. So these are few questions. There are other questions which remain. These questions we will cover, remaining questions, in the next lecture. So that's about it. That's about it. And I'll see you then on Friday. And I will complete this topics, past papers, topical questions. And meanwhile, if there are any questions, you can always ask me. There are maybe from 12 to 18 or 19, there are so many questions left. We will do those in next class. Any questions?